All right, so today we're going to be going over this practice quiz. Okay, the practice quiz on chapter 16 does have some formulas and some little things that can be kind of tricky. So please, if you have questions, let me know and I'll try to answer them as quickly as I can, okay, in the best way. So this here says, the American Red Cross says that about 11% of the U.S. population has type B blood. Letting you know for your actual quiz, it's going to be the same exact kind of problem, the same exact, pretty much the same kind of questions, just it'll be like type O or something instead of type B, okay? And then like instead of like the 10th or this, exactly 2 out of 20, it's be slightly different numbers, okay? But same kind of questions, so same format. If you follow what I do, you should be just fine. Should. All right, so first question says, how many blood donors should the American Red Cross expect to collect from until it gets a donor with type B blood? So this is the geometric model. Okay, I'm gonna make a little note here. This is from the geometric model, which was like the first thing we did. And that was saying that you need your p-value. In this case, our p-value is going to be 0.11. Okay, the p-value is a success, meaning we want a type B blood person. That would be a success. Anyone that is not a type B blood person would be a failure for this problem, okay? So we're going to go ahead and find the expected value, okay? And the expected value for this kind of problem, okay, they say is 1 over P. Now, this mu is going to change throughout this problem depending on what kind of problem it is. So you're going to see mu come up maybe one more time. Yeah, 1 or 2 more times. And the other time, it's going to be a little bit slightly different type of formula because that was the binomial model. So for the geometric model, we use 1 over P. For 1 over P, it'll be 1 over 0.11. Okay, so if you take a calculator and you say 1 divided by 0.11, what do you get? Let's see here. I have the answer. I'm just double checking. So whenever you take a number, like a decimal, it's less than 1, like 0.11, and you take 1 divided by that, it always gets bigger. Okay, it actually will increase. So I'm going to round this to just 1 to just a tens place. So 9.09, I'm going to take that 9, that 0.09, and round it up to 0.1. So I'm going to say 9.1 donors. So on average, whenever they go to a location, whenever they're doing a blood drive, maybe at our school or something, right, they would say, hey, like we would expect on the 9th donor, that might be our first time getting somebody to get a type B blood person. Okay. So you got to imagine there's other blood types with higher levels than 0.11, right, than 11%. And so they might be found first, but they say by the 9th donor, you should have your first person, okay, with that information. All right, moving on to question 2. What is the probability that the 10th blood donor is the first donor with type B blood? So you've got 10 donors, and the first 9 are not type B, but the 10th donor is type B. So we want to know the probability that there's 9 not type B, comma, type B on 10th. Okay, so we're going to have 9 in a row. So the first one's not type B, the second one's not type B, the third one, right, not type B, and the fourth one, and the 5th, and the 6th, 7th, 8th, 9th, and then the 10th one is type B. So I'm thinking of ands here, right? So you're multiplying the same number 9 times in a row, but at this level with this stuff, we say it like this. We're going to say, oh yeah, if my P is 0.11, my Q is 1 minus P, so that's going to be 1 minus 0.11. So that's going to be 0.89. So I'm going to throw a 0.89 because that's the failure rate. That's the people that are not type B. Okay, so I calculated this number, my Q, right? The formula says take Q to the power of 9, because we're going to have 9 in a row. And then we have on the 10th is going to be that one we want. So that's basically to the first power, right? You don't got to write that first power, but I like to write it sometimes. So once again, you've got 9 in a row that are failures. And then the last one boop, is that, okay? So I have the answer. I'm just going to triple check it. So we have 0.89. So let me show you guys one thing here. So that's that. Okay. Then I'm going to times that by 0.11, and I get 0.385392, blah, 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 blah. So I'm going to go ahead and I'm going to round this just to 4 decimal places. And I'll remind you guys on your actual quiz for your similar question, I will tell you how many to round to. That way when you type it in, you get it correct. Okay. All right. So 0.0385. That's the probability that the 10th donor is the first donor with type B blood. If you guys are using, let's do this right here. Let's say, if you guys use the Google calculator, I like their calculator. So I'm going to show you that real quick. Let's go to a tab. All right. So if you guys are here at the Google calculator, you could do the same thing. You can say 0, parentheses 0.89. Now, good job. Come on. Parentheses 0.89. And then if you want to do an exponent with a Google calculator, which is, I think, you can use this calculator for every problem on here just fine. So 0.89, and you push the X to the Y button here, and then we say 9th, okay? And then you can simply just say times, and it knows to just go back down to here. And you can do the first power, but first power doesn't really do anything. So the same answer we got from the phone calculator, right, should be the same answer that the Google calculator gives. And so as you can see, that's what we got there. Okay. You know, let me change it slightly. All right. Okay, any questions so far? There, this first one, how many until you get the certain thing you want? You say 1 over the p-value is what's called the expected value from the geometric model, and we got 9.1 donors. For the second question, we have 9 in a row that are failures, and the 10th one is as the success. So success is type B blood. The failure would be anything not type B blood. And so 0.89 to the 9th power, failures to the 9th power times success to the first power. There we go. Okay, so what is the probability that exactly 2 of the first 20 blood donors have type B blood? This is where it gets a little tricky. Okay, the probability that you get exactly 2 out of 20. So we'll say 2 out of 20. So not less than 2, not more than 2. That's the next question. Okay, this is exactly 2. So when it's exactly 2, or exactly a number, expect maybe something like 3, 4, 5, or something like that, right? And maybe it might be 3 out of 10, or whatever it is. Remember, it's going to be new numbers, new stuff, but it'll be the same kind of problem. We'll set a probability that your donor is going to be 2. And I'm going to write this. We can write this like this and say, remember the NCR thing? It was the NCK. Okay, that's going to be, we can do 20 C2. Okay, and remember when we had the NCK, it was the N factorial on top, and then it was the K factorial multiplied by the difference, the N minus K factorial. Okay, And then this is going to be multiplied by how many successes that we're looking for, right? The 2. So it's going to be successes, which is 0.11 to the second power. This times the failures, with the non-type B blood, so 0.89. And now, since there are 2 successes out of 20, exactly 2, that means there's exactly 18 failures out of 20. Okay. Now, you might see this written a different way, so I'm going to show you guys a different way to write this. Some books, some materials will write it like this. Instead of saying 20C2, they'll say 20 and then 2, like this. It looks like a fraction with no fraction bar. Okay. In fact, there's a number of calculators that when you type this kind of stuff in, there's a way to type it in like this, and this means that. It's a really kind of a weird and awkward thing. But this way is, I think, a little easier and cleaner to write than this. But just know they mean the same thing. That's a lot more if you guys delve into more probability. This doesn't really come up outside of this chapter. Okay, you'll see it for 1 or 2 questions maybe on your test, but other chapters don't do a lot of the combination stuff. That was kind of just to this unit. All right, so when I calculate this, let me show you how to calculate this in the Google calculator. Okay, so for the 20 factorial divided by the 2 factorial times 18 factorial, right? So you can say 20 factorial, a little exclamation point, divided by, now I'm going to show you, put the parentheses and do the k value, okay, the value that you want, which was 2 factorial, and then multiply that by the difference. So 20 minus 2 is 18 factorial. Okay, so whatever, these 2 numbers should add up to this number here. And I get the answer. Instead of doing all the work, okay, writing all the stuff and doing all the things, they say it simply equals 190. So I'm going to go ahead, I'm going to jump down to this one here and call this 190 for this, okay? And then 0.11 to the second power. So 0.11 to the second power. Oh, you guys didn't see what I wrote. I'm so sorry. Okay, so I took the 20. So it's 20 choose 2, right? 20 choose 2 is kind of how we say it. Times the success, and we want 2 of them, so it's the second power, times the failures, which is the difference, which would be 18 failures, right? Out of 20, if 2 are success, 18 are failures. So it's 20 choose 2, which we already calculated, and we got the 190, and it's the 0.11 to the second power, which we get to be 0.0121. And then we'll say 0.89 to the 18th power. Okay, I got 0.0121. And then this one's going to be 0.89, but this one's going to be to the 18th power. That's awesome, right? That's lovely. Let's say 0.1227. Okay. If I multiply these all together, okay, if I multiply those 3 numbers together, let's see what we get. That will be the probability that exactly 2 of the first 20 donors have type B blood. So 190 times 0.0121 times 0.1227. Okay, I'm double checking my numbers, make sure I typed it in right. The decimals are there. No negatives, no weird stuff, no pluses or minuses. So I get 0. And I'm going to round this just to keep it with the 4-number theme. Okay, that is the 10,000ths place. 282, and it says 0.8. So I'm going to round that to a 1. In fact, the actual answer, if you do it by saying, what do we say? It was the one that 20 that 20 choose 2 is going to be 190 regardless. But if I do this and say 0.11 to the second power and then multiply this by 0.89 to the 18th power, we get a slightly different number, which should be 2822. So just know that this number is going to change slightly if you type it all in together without rounding. Okay, so this is close, but this would be better. So I'm going to type in there with multiple. So when you guys type your answer, you have to type the numbers in again. I'm going to try to make sure that if you round, your number will be close to, and you can kind of make sure you do that. But I will go and double check that if you are doing something slightly different than how I'm doing it for my answer key, that it is at least close enough that I know you did the right thing, especially if, you know, like these numbers are going to get way off if you're not doing it right. If you're doing it correct, but you're doing some rounding stuff, you're going to be extremely close. Okay. It'll be obvious that you know what you're talking about. Okay. So once again, exactly 2. So 2 out of 20, which would be 20 choose 2. Okay. 20 choose 2 is 20 factorial divided by 2 factorial being multiplied by 18 factorial. That times the success, second power, failure, difference of that, 18th power. Okay, so 190, this, that, all the way down. Questions so far? Okay, give you guys another, let's see, about 30 seconds to copy this down. I don't want to go too fast. So this next question is going to say the probability that at least 2 out of the first 10 had type B. So it's going to look something like this. They'll say something like, okay, probability of at least 2 out of the first 10. So probability of at least 2. So here's your options. What you can do is you could do this probability like this for 2, and then do this again for 3, do it again for 4, 5, 6, 7, 8, 9, and 10. So do this essentially what, 8 times? Okay. And do it for 2, do it for 3, do it for 4, do it for 5, 6, 7, 8, 9, 10, and then add those all together, because it could be 2, or it could be 3, or it could be 5, or it could be 6, or it could be 7, or it could be 8, or it could be 9, or it could be, 10. That sounds like a big pain, right? Because you got to do all these 10 choose 2, 10 choose 3, 10 choose 4, and then each time, right, it's going to be times that number. It's going to be a big pain. So there is a slightly faster method, and that is to consider that if it's at least 2, we can do the opposite and actually calculate that. Meaning, I could say 1 probability, which is 100%, take away the probability of getting less than that, okay? Which we would say less than that is simply x is less than or equal to, if it's 2, I'm going to subtract it to get to 1. Okay, if this was 3, I would write less than or equal to 2. If this said 4, I would say less than or equal to 5. If it was 4, it'd be 3. If it was 5, it'd be 4. You always take away 1, okay? Because this is kind of what you don't want. You don't want it to be 1 or less, right? You don't want it to be 1 or less. So if you figure out this probability and you take that away from the 100%, right, the 1, that would remain 2 or greater. So it's kind of like a shortcut. It's kind of like taking like the side door or something, okay? It's a pretty cool method. It's still kind of can be a lot of work, okay? But it's considerably less work than the alternative, than doing it like this, but for every single 2 through 10. Okay, so just be prepared for this problem on your test, okay, on your quiz. So I'm going to go ahead and say 1. Take away the probability of x is less than or equal to 1. So we have to consider 1 type B blood type out of 10, and then we got to consider 0 type B blood out of 10. So I'm going to put these a big bracket there and say I'm going to use this notation right here. Okay, not the 20 choose 2. I'm going to say 20 choose 2, but it's going to be like this fraction with no fraction bar. Okay, the way this looks here. I'm going to say, and I'm going to start. You can start with 0. You can start with 1. I'm going to start with 0, and I'm going to count up to 1. So 10 choose 0. So out of 10, none have type B blood. So my success, which is 0.11, there's none of them. These numbers here should be the same. Okay, like how those numbers were the same. Okay, those numbers will be the same. And this is being multiplied, my P and my Q. And this one is always the difference. So if 10 and 0, okay, you get 0 here. This is the difference. Remember how it was 20 and 2, so it was 2 and 18 because those add up to the total. These should add up to the total here, okay? And I'm going to add this probability to 10. This time choose 1, okay, because it has to be 1 or less. So you can start with 1 and then make this one 0. You can start with 1 and make that one 0. But when you add things together, it's going to, like using order of operations properly, it shouldn't matter which one you do. And if this one said, let's say it was equal to or less than 2 or less than or equal to 3, you would do this multiple times until you counted up to this number right here. Since this is the last one, because 1 and then 1 here, I'm going to go ahead and write this out, but then I'll be done with this problem. I'll have to simplify it, but I'll be done writing it out. So if this number was like a 2, I would do 0, this, 1, this, 2, that. If it was a 3, it would be 0, this, 1, this, 2, this, 3, this, and close it off. Okay, so there's a great chance on your test or on your quiz that this number is going to be different than, these numbers here will be different right than this number there. Okay, all right, so success, my P is still 0.11, my failure is still 0.89. And once again, those numbers have to be the same. So if that was a 0, because 0, this is 1, so that's the first power, and that's going to be the 9th power now. Okay, and I'm going to close that off because it said just less than or equal to 1. And for these probabilities, right, we're only using positives and zeros, so 0 and 1. If that said 2, I would do another one. And if it was still like 10, choose 2, it would be 2 and 8 or something like that. Okay, so so that should be everything you guys need to kind of know for now. All right, so what I'm going to do is I'm going to plug this stuff into a calculator. Okay, give you guys a moment to copy this stuff down. All right, whenever you have parentheses and you kind of have outside groupings like this, you should use like these brackets like that. They should kind of be the same size. I didn't do that the best, but okay. So I'm going to say 10 choose 0 would look like this. So 10 factorial. Actually, you know what? Let me do, yeah. So 10 factorial divided by parentheses 0.11 fact. What did I do that for? It was 0. All right. Oh my gosh, just stop all this stuff. 10 factorial divided by 0 factorial times 10 factorial. Now, it might sound weird. You're like, Mr. Atterbury, how do you divide by 0? Okay, 0 factorial equals 1. So 0 factorial can be something you divide by. How cool is that? So 10 factorial divided by 0 factorial times 10 factorial basically leads to 10 divided by 10, or 10 factorial divided by 10 factorial, which is just 1. Okay, and then 0.11 to the 0 power is going to just be, so this right here, so that's going to be 1, that's going to be 1, and then so really it's 1 times 1 times 0.89 to the 10th power. So 0.89 taken to the 10th power. Okay. So just for the sake of rounding, I'm going to write some more numbers out here. Let's go to 6 numbers, 31, 18, 17. So I'm going to round just to 4 digits at the end, but hopefully this helps keep us at a closer answer. Okay. So I just took this 10 to the 10 choose 0 is simply just 10 factorial divided by 10 factorial, which gives you just the number 1. 0.11 to the 0 power. Anything to the 0 power is just 1. So 1 times 1 times this number, 0.89, the failure rate, right? The Q to the 10th power. Now I'm going to add this to 10 choose 1, which will be not 1 anymore. Okay, it'll be slightly different. I think it's like 10 or something. And then 0.11 to the first power, and then 0.89 to the 9th power. So here we go. 10 factorial divided by 1 factorial, which should just be 1 also. That being multiplied by 9 factorial. Okay, so these two numbers here, once again, should add to the left number over here. That equals just 10. So I went ahead and just kind of crossed this off and said that just equals 10. 0.11 to the first power. Well, anything to the first power is just that one thing, right? So that one's already kind of done. 0.89 to the 9th power, however. So I'm going to say 0.89 to the 9th power. Now I'm going to go ahead, I'm going to multiply this by 0.11 and then multiply that by 10. So 0.11 and 10 came from those numbers right there. Okay, so I did this first just to make sure I'm not making any mistakes, right? I just do that first, get that answer, and before I kind of round it, I'm going to multiply by those things. And now I'm going to do this once again to 6 decimal places, but at the very end, I'll just cut it down to 4. So 0.3553, 38, sorry, 53, 92. Okay. So 1 minus 0.3111817 plus 0.385392. Let's add those together. So I'm going to say 1 take away. I'm just going to go ahead and just do it like this because Google rocks. I love it. 311817 plus 0.385392. So that's my final answer. I think you can even kind of go through this and look at your previous work too, which is pretty cool. If you've never seen this before, Google has a cool way to look at your old numbers. You just got to hit that little history. It's like a clock with it's like a rewind type thing. So I'm going to round this to 2 decimal places. So 3027, but it's got a 9 after 7, so it's going to be 3028. So 0.3028. That is the probability that at least 2 of the first 10 blood donors had type B blood. So I chose the 1 minus the opposite. Okay. So if you wanted at least 2, what's the opposite of at least 2? It would be 1 or less, right? Or less than 2, right? X is less than or equal to 1 is the same as saying less than 2, okay, without the equal sign. So a few ways you could see this, but this way seems to be the fastest because the alternative would be don't do the 1 minus, but do the 2 plus the 3 plus the 4, 5, 6, 7, 8, 9, and 10. You could write this out like a bunch, right? But this right here is considered a shortcut type method, and it seems to kind of work more reliably because it's less things you're doing, therefore potential for less errors. Okay, 2 more to go. If you did not like this one, then you'll probably like this next one. This next one is pretty dang straightforward. So, and here's what I got to, and here's what I'll tell you guys too. If this 3 and 4 seems kind of difficult, or especially 4 seems kind of difficult, one strategy, one way to keep confidence on a test like this or a quiz like this, since a lot of math I feel is just having confidence. You have confidence, know what you're doing, you're going to probably find more success. Have confidence that if you miss one question here, you'll probably still be okay. You can probably still get like an A or B on this quiz. Okay, so try your best, do your best, but don't avoid the entire test because you don't want to do one problem. Okay, don't give up because one problem feels kind of tough. Okay, this next problem is pretty straightforward. Okay, if anything, this should be everyone's, I think, probably favorite problem. Kind of like number 1. Okay, number 1 was pretty straightforward, right? Number 1 was like this. Number 1 said 1 divided by P, final answer. Okay, kind of similar here. Okay, the blood drive has a total of 150 donors. Okay, so our N equals 150. So I just stop right there and say, I know N equals 150. Assuming this is a typical number of donors for a school blood drive, which not for Serrano High School, we'd always have like 500 or so. So you might want to think that when I have the quiz, for the actual quiz, it'll probably be somewhere around 500, okay? Because that's kind of what we do at our school. Assuming this is a typical number of donors for a school blood drive, what would be the mean and standard deviation of the number of donors who have type B blood? So remember I told you a little bit ago how it's going to be slightly different later on in this quiz. So for this one, okay, we're going to use the binomial model. Binomial. So I'm going to put like a little note here. Binomial model. Okay, this is what we'll be using for this one. So we're going to say they want the mean and standard deviation. So the mean is going to be the new mu, okay, which is, they say, is the number of people we have times our probability of success. So 150 times the success rate of 0.11, my mean is going to equal 150 times 0.11. I get 16.5. Okay. So we're going to round this to like just a couple places, but for this one, 16.5, we can just say 16.5. So out of 150 donors, we would expect 16 and a half. So basically around 16 or 17. And then number 6 goes into the normal model, which we'll kind of like talk about that when we get there. But 150 donors, bam, right there. So standard deviation. You can write standard deviation. I'm going to say capital S, capital D. You can do lowercase s, lowercase d. They all kind of mean the same kind of thing. But sigma, my standard deviation, is going to be the square root. Okay, we're using the binomial model. They say that the standard deviation is the square root of n times p times q. So calculator work. Here we go. That's going. Oh, let me type it out. So this is what I will type into the calculator. Is be 150, right? 0.11, 0.89. So I'm going to show you on Google's website how to plug that into the calculator. Okay. So the number of people, the number of donors, times the probability of success, times the probability of failure. So type B and then not type B, all times that 150. All right. So in Google, we would say this. I'm going to go ahead and put the square root. And then I'm going to, it already gives you parentheses. I'm going to say 150 times 0.11 times 0.89, close that off. So this whole thing being multiplied by the square root of all that, I get that number there. Let's just do 2 decimal places. So I'm going to say 3.83. It's 2 after the 3, so I'm going to keep it at 0.83. I'm not going to bump that up to 0.84. I'm going to call that 3.83. Okay, so right there, that's the answer. The mean and the standard deviation of type B blood. So what that means is if you go to the blood drive, or the American Red Cross, if they're holding a blood drive at this school, and there's 150 people they expect to show up, and they want to know, okay, how many type B blood donations would we expect out of 150? We would expect about 16 or 17, right? But there's a little bit of variance there, right? There's that standard deviation that we use, and something about that 3.83 is going to help figure out like our general range, kind of going old school we talked about earlier this year. So any questions before we move on to this last little section? This last section is a lot of writing. Well, yeah. So generally speaking, on a question like this, there are different ways you can do this, but I'm going to show you the way that seems to be the easiest. Like, here's how you do it. You know, like I know generally in math class, we don't like a lot of the fuzzy gray area stuff. Like, just show me how to do it, right? You want stuff like that. So things like this make math easy. Things like this make it, this class particularly, kind of tough. So we're going to start by looking at our mean and standard deviations. You're going to use the numbers you got from number 5. So it'll be helpful for you guys to be doing like scratch work while you're doing this quiz. That way you don't got to have to go back and recalculate stuff. Okay. So we're going to start by saying, all right. So if we're expecting 16.5, okay, let me back up a second. Let me actually read the question, huh? Surprised by the low number of type B blood donors at the blood drive, the American Red Cross wonders if the 11% estimate was too high for your area. How many type B blood donors would it take to convince you that this estimate might be too high? Okay, so they didn't tell you how many type B blood donors were at the drive. So before they give you an answer of like, let's say they were expecting 16 and let's say they got 14 or 13 or 12 or 11. Like at what point would you say, yeah, maybe my area just doesn't have a lot of type B blood people, right? Maybe there's more type B blood people, maybe the next town over or the next state over or something. I don't know, right? You kind of understand, right? When we have like a percentage like this, like 11%, right? It's not going to be exactly 16 or 17. Like it might, right? There's a chance it might, but there's a good chance it's going to be close to that, but not perfect. At what point would you say, ooh, that's a pretty low number? Maybe my area is less than that 11%, and maybe they should just look at readjusting that for this area. Maybe they think for feeling it should be 8% or 7%. I don't know. Okay. So how do you calculate something like this? So first, I'm going to use the normal model. The normal model is that bell curve, right? It's that thing where we usually think of outliers as being 2 or 3 standard deviations from the mean. So what I'm going to do is, before I can use the normal model, I gotta do the 10 success, 10 failure rule. So I'm gonna say n times p. I already know that is 16.5. So I would expect, on average, out of 150 people, I would expect 16 or so to have type B. And the failure rate, the people that are not type B, is n times q. And when I do n times q, I get 133.5. I mean, the alternative is you take 150 and subtract 16.5, right? These should add up to 150. This is the people with type B. This is the people without type B. So once again, the Red Cross says, we didn't get enough people, but they didn't tell you how many people was low. So if you heard this number, do you think it would really be low, or you think maybe they're just kind of being like silly and dramatic, going, it's close enough? You know, you wouldn't expect that perfect number. But what number would be close would be at that point where you're like, that's just way too much, or that's way too little. So what we're going to do is we're going to say, I'm going to state how I'm going to come to my conclusion, and then I will state my conclusion. Okay. So before I actually calculate this number, okay, I'm going to say, I'm going to use the normal model. Oh, wait. I'm going to use in capital, because this is actually a proper noun here, right? Normal model. Not just any old model, but the normal model. Like we use the binomial model. This is the normal model. Okay. I'm going to use the normal model since there are at least 10 successes and 10 failures. Since there are, I'm just gonna say it like this, but just know we're making a prediction here, okay? Since there are at least 10 successes and 10 failures, and I'm gonna put predicted here at the end to say this is just my prediction based off the numbers we have. So I'm gonna use a normal model since there are at least 10 successes and 10 failures. Since there are at least 10 successes and 10 failures, predicted. So out of 150, I would expect about 16 to be type B, and about 133, 140, or 133, 134 to be other types of blood types, right? So I'm going to go ahead and say, I'm going to take a moment. I'm going to say the mean and the standard deviation, right? I'm going to say mu take away 2 times sigma will give me a lower boundary for outliers. So we talked before about this idea of the mean plus or minus the standard deviation. And generally speaking, at a very basic level, okay, it's generally accepted that if you add 2 standard deviations, you find the outliers that are too much. Okay, think about Goldilocks, right? It's too much. If you subtract 2 standard deviations, they say, kind of like Goldilocks once again, that it's too little. Okay, and then anything in between is just kind of normal. It's just kind of like, it's within that acceptable range, right? But beyond this, if they say we can use the normal model, which we can, and hint, hint, hint for your actual quiz, you can. Okay, I'm letting you know now. But make sure you calculate it and prove it to me. We're going to go ahead and we're going to calculate the mean minus 2 standard deviations, because that's going to be the Goldilocks too small. Okay, in certain cases they say you want to use 3, but for this case we're just going to use 2. Okay, generally speaking, most of the time you want to just use 2. All right, so we're going to go ahead and say we're going to say the mean, which was 16.5, take away 2 times the standard deviation, the sigma, which was 3.83. And that's going to equal, it should be about 8 something, 8.84. Yeah, I'm typing in the answer that I've already done. Good job. 16.5, take away 2 times 3.83. Okay. So once again, I'm using the mean minus 2 standard deviations. So I get 8.84. Okay. So at 8.84 is where the boundary line lies. So if we got 9 blood donors, that would be kind of low, but I wouldn't think that is like extremely low. Like it's close, but 9 donors would be just above that boundary line. Okay, so one more time. 9, 10, 11, 12, 13, 14, 15, 16 is kind of like the average, but like the low end of the average, but they're all kind of acceptable part of the averages. Okay, so if we got less than 9 donors, so 8 or less people, that would convince me that 11% would be too high for this area. Okay, so I'm going to say it like this. I'm going to say it. So I would conclude that the estimate of 11% would be too high if the number or amount, right, something like that, or the number of type B donors is less than 9. Okay, anything kind of along those lines would make sense, but that's what you're kind of doing for a problem like this. This is how you justify your answer. Okay, this is how you kind of go through this process. Okay, as you can say, I'm going to look at my number of successes, my number of failures that I'm predicting. I'm expecting, right, about 16.5 people, about 16 or 17 plus or minus a little bit of people to have type B, and then likewise about 133, 134 plus or minus a little bit to not have type B. Okay, so if they're coming at me saying that, hey, your area, the 11% was too high for your area, you would say, well, how many did you get? Because according to my calculations, if you got less than 9, then yeah, I would agree with you, because 8 is pretty far away from 16 according to our model. Anything between like 9 and about what? About 9 and about 22 is kind of what you would expect. You know, you don't ever expect things to go exactly how you want them to be, right? You should never really expect that with this kind of stuff, in these kind of predictions about life and humans and things that kind of happen, right? We can only make the best predictions that we can. So I'm going to go ahead. I'm going to stop this recording. And when I stop the recording, I'll keep opening it up for questions. I will upload this video